In this second part of the Cambrian explosion, I'm going to summarize the 4 most notable features of the Cambrian explosion. First, please write down the following 4 questions. Number 1, what are these 4 outstanding characteristics? Number 2, how many different animal phyla appear during the Cambrian explosion? 3, name 4 major changes caused by the so-called substrate revolution. Number 4, what is the difference between plankton and nectar? Let's jump into straight at the beginning here. Characteristic number 1 of the Cambrian explosion. What you see here is a picture of all the different animal phyla that can leave a fossil record. You can see here, for example, Demospongia, these are sponges. You see here, Calcarea, also a type of sponges. Echinoderms, which include sea urchins, sea stars, different types of worms. We see here, this is, I think, well, I don't know, some philosopher, that's a vertebrate, another worm, Platyhelminthes, brachiopods, mollusks, different types of worms, rotifers, and arthropods, and here's Placosaurans. Now the important thing about the Cambrian explosion. Every single phylum that can leave a fossil record appears during the Cambrian explosion in the first 20 million years of the Cambrian. Every single one. And not a single new phylum appeared since then. Characteristic number 2. In the earliest Cambrian, in particular the Tromodian, we have the massive appearance of hard fossils, skeletons, teeth, claws, armor. The Cambrian explosion is characterized by a massive emergence of hard skeletons and hard fossils. Characteristic number 3, the so-called substrate revolution. This is the appearance of vertical burrows. Remember, I explained to you that in the Ediacaran, we had the emergence of burrows, of trace fossils at around 560 million years ago. These creatures, however, you can only find on the surface of fossils. That means if you find a worm track, the worm track is parallel to the bedding plane. These things are moving along the bedding plane, looking for food and mining microbial mats. However, in the Cambrian, we start to see creatures that first move horizontally and then they decide, whoa, maybe there's food down there too. And they start burrowing into the sediment and come up again. That is new and that's very important. And they cause the so-called substrate revolution. The first creature that shows some strange behavior is the trace fossil Traptychnospedum. This is shown on the picture here. And you might recall that the appearance of that particular fossil is a definition of the beginning of the Cambrian. In the next slide, you will see some vertical burrowers. For example, you can see here, this here is an ancient sea floor, a sandstone. And underneath here, you see this little U-shaped feature. It's quite inconspicuous, but a paleontologist will tell you that is a vertical burrow. This is a creature that first moved along the bedding plane, then it burrowed a few centimeters into the sediment, and then it came up again, or it even lived in this U-shaped burrow. These things do not exist in the Ediacaran. This is Cambrian. Here, even better, a fossil called Gyrolythis. Gyrolythis, again, here's a sediment. This creature starts drilling itself in a spiral into the sediment. This is a very efficient way to mine for food while avoiding mining the same sediment a second time that you've mined before. All of this burrowing into the sediment causes maybe the single most important feature of the Cambrian explosion, namely the so-called substrate revolution. And I will explain what that is in the next slide. Here on the left, we have the Ediacaran. You can see here is sediment maybe the sediment of relatively shallow water in the tidal zone underneath the wave action. And each of these lines here is an event, maybe a storm event, a wave event. And on the surface of the ocean floor, we have a microbial mat. Maybe you might want to call it a flat stromatolite. And what you can see here are, this green is the microbial mat, and here you see Dickinsonia, and here you see Chaniodiscus, and here you see something, cyanobacterial balls called Beltanelliformis. And the sediment is beautifully laminated. Nothing is disturbing it. The substrate is, as you can see here, it is firm. This would be quite hard and jelly-like and would be difficult to stick your finger into the sediment. It is just simply firm. And this substrate, the mat, is, well, that's what the creatures eat on the surface. Now this changes entirely in the Cambrian. So I'll show that here now. This here is what the substrate in the Cambrian looks like. It has changed quite substantially. You see here suddenly vertical burrows. Here's a bivalve, a bivalve that burrows into the sediment, and there's worms that have left tracks. See, this is a U-shaped worm. And here is a trilobite that's just mining, is bulldozing the surface. The microbial mat is done, it's gone. The lamination of the sediment is gone. And there's some very important things that happen as a consequence. A, the sediment is not firm anymore. It becomes yogurt-like, becomes soft and soupy. That entirely changes the carbon cycle, because here, the organic matter of the mats is simply buried and disappears in the sediment, while here, the organic matter from these mats and from other organic matter sinking down, raining down into the sediment is mined again. The burrows are digging it up again and eating it, and the carbon is recycled more efficiently. So the substrate evolution, one, changes the carbon cycle. Two, these burrows, these guys here and these guys here, are aerating the sediment. They're ventilating the sediment. They're burrowing into the sediment and bring oxygen down there. That means the sediment suddenly offers ecospace where other creatures can breathe. Creatures can live within the sand, underneath the surface, because there's oxygen that they can breathe. Number three, fossilization changes entirely. While soft creatures like Dickinsonia can be fossilized when they get buried underneath a layer of sand, here Dickinsonia would not be preserved because worms would churn up the sediment again and destroy everything that's soft and within the sediment. So number three, fossilization changes. We call this a so-called taphonomic window. Soft creatures in these habitats will not fossilize anymore, changing the view that paleontologists have of what's actually going on. It is a bias, a taphonomic bias. Taphonomy is the science of studying how dead things are preserved. Characteristic number four of the substrate evolution. Here in the diagram, nutrients like phosphorus and nitrate are buried forever. While here, these creatures are digging up the sediment and bringing phosphate and nitrate back up to the surface and release it back into the water column. So this is an efficient recycling of limiting nutrients, speeding up the biosphere. More fuel, more energy, more nutrients, faster evolution. Now, characteristic number, and by the way, if you want to rehearse this, you can stop the slideshow, and underneath the slide, you can find here a summary of these things that I've just said. Characteristic number four of the Cambrian explosion, the appearance of so-called nekton. Now you might be familiar with the word plankton. Planktonic creatures are little algae and other things that are hovering in the water column, mostly towards the top where there's light, but these things cannot swim. They are just moving around when currents are moving them around. So plankton are things that are hovering in the water column. But nekton, well, you see here shrimp and other creatures that are swimming around actively in the water column. That is called the nekton. Nectonic creatures can actively spend time in the water column by propelling themselves by swimming. The earliest creatures and all creatures of the Ediaca biota lived on the sediment surface. And then some of them learned how to lift off and fly within the water and become the plankton. The biggest change that this causes is in a creature is the following. It's the so-called fecal matter express. A creature like the shrimp here is eating plankton and then it's digesting it. It is making a little fecal pellet or a little shit ball and spewing it out. And these pellets of poo sink extremely quickly to the water column. So if this here is a dead alga that will sink very slowly to the water column like that, it might take weeks and months to hit the surface of the sediment, while a little poo parcel created by shrimp goes like that. That is called the fecal matter express. It entirely and completely changed the carbon cycle again. These were the 4 major features of the Cambrian explosion. And in the next slide, we will look at the 5 major questions that the Cambrian explosion poses.